Class 11th. So today we are going to start this chapter number 4, motion in a plane. So in previous chapter we observed that object is moving in a straight line. It can move in the direction towards the right hand side, it can move left hand side, but it was always along a line, and therefore we were able to calculate its distance, displacement, velocity, instantaneous velocity, average velocity, acceleration, and all. We were able to apply equation of motion, and we also found out the relative velocity of any object. So in this chapter we will be discussing the object is moving in a plane. However, it can move in 3 dimension also, but that would be complicated for us right now. So one by one we will discuss everything. Right now we are going to discuss motion in a plane when the object is moving in a plane. When object moves in a plane, then its position requires 2 coordinate, like we used to do in class 10th coordinate geometry. So we need 2 points to describe the position of a particle. We will do this in detail in the coming lectures. So let us first define what are scalars and vectors, because the chapter starts with the concept of scalars and vectors. So the physical quantities can be divided into, all the physical quantities are the quantities which can be measured directly or indirectly, as you are all aware about that. Scalar quantities are those quantities which have only magnitude. You know the examples of such quantities like distance, speed, time, mass, etc. Whereas vectors are those quantities which have magnitude plus direction, like velocity, displacement, force, acceleration, etc. So scalars we are already aware of. We can deal with them, we can add them, multiply them like numbers, but vectors cannot be added as such. So in scalars 2 plus 3 is 5, but in vector it is not necessary that 2 plus 3 always gives you 5, because in that case the angle will also be responsible for that. So what is the importance of angle in vectors? We will be doing this in this chapter. So let us move on to the next slide. Let us see here, we have 2 graphs. So in this graph A, any particle which is moving in a plane. Right now you understand what is the motion in a plane. Motion in a plane is where the object is moving in on a surface. Its position requires 2 coordinates if we want to describe the position. So initially the particle is at P, right? And here if I want to describe its position, then position is always measured from some point of reference. So observer is at origin, and for the observer the position of particle P is from O to P. Arrow from O to P gives us the direction, that the direction is from O to P, right? After that the particle starts moving. We cannot show here time axis, right? So object now reaches at point P dash along the path shown by this blue line. So the new position of this particle P dash is, as observed from origin, is OP dash. So the new position is OP dash. Here the displacement, if you see, is P dash P. The displacement is P dash P, and its direction is P dash. Its direction is from P to P dash. If you see the distance is little greater than displacement. So you are already aware of this thing, that distance is always greater than or at the most equal to the displacement. Distance and displacement are equal only if the object is moving along a straight line without moving back. In graph number B, let us observe. So the particle is at P, then particle reaches B along A. So it reaches B along A. The displacement is B dash, but the path length or the distance is PAB. The displacement is PB, right? Whereas the displacement is PB, whereas the distance is PAB. You can see PB is smaller than PAB. So you are already aware of this thing, that displacement depends on initial and final position, whereas distance depends on the path taken. So distance is always greater than equal to displacement. Displacement is a vector quantity. It is shown by direction, and you can see the direction. So suppose this Q is final point. So the displacement is PQ, whereas here two cases are given. One, the path, you can reach Q from P to Q, you can reach Q via P, A, B, C, Q, or via P, D, Q, or you can go to Q directly. In all these three cases, the displacement is the shortest path taken, and it has definite direction. So displacement is a vector quantity, whereas distance is a scalar quantity. However, both are measured in meter. So with the help of dimensions, you cannot differentiate between distance and displacement, right? So let us see what is written here. Therefore, the magnitude of the distance is either less or equal to the path length of an object between any two points. So displacement is always less than equal to distance, right? So we are well aware of this concept. Let us move on to the next slide. So we are now aware of the vectors. That vectors are the physical quantities which can be expressed with the help of magnitude, and they have direction. Now let us talk about equality of vectors. When will we say that two vectors are equal? So two vectors are equal when they have same magnitude and same direction. So by same direction, I mean they must be parallel. Their position can be anything. So suppose one vector is this and other vector is this. So if they have same length, suppose this is 5 centimeter, this is also 5 centimeter. If they have same length and they are parallel, but not necessarily they are one above the other. There can be some gap between them, but they must be parallel. In such case, the vectors are said to be equal. So if they are parallel and their length is same, the vector is called equal vector. Similarly, there is a concept of opposite vector. Two vectors are said to be opposite vector if they are same in length but opposite in direction. So if this is vector B, this vector will be minus B. They are opposite vectors. What about these two vectors A dash and B dash? These two vectors are not equal. Why? Although their length can be same, but their direction is not same. So in such case, these vectors are not equal, whereas these vectors are equal, right? So you all are aware that we can add or subtract the physical quantities only if they have same nature. Means length can be added with length, displacement can be added with displacement. So you can add and subtract the two similar physical quantities, right? But you can multiply two different physical quantities. Here we are dealing with free vectors. What do we mean by free vectors? By free vector, I mean that if this is vector A, I can place it anywhere keeping its length and direction same. Then this vector is also called vector A. But there are vectors where you cannot change the position like that. Such vectors are called localized vector. You will study about these localized vectors in higher classes. Now let us see what happens when we multiply a vector by a real number. So suppose I have a vector A and I multiply it by some number lambda. Then by multiplying a scalar with a vector, I simply increases its magnitude that many times. Let us consider this example. Here we have a vector A. If I multiply it by 2, then its direction will not change. Then what will happen? The direction will remain same, but its length will become 2 times. So if the length is A, multiplying by 2 will increase the length by 2 times. So here we have two vectors. I told you about opposite vectors. They are equal in length but opposite in direction. So A minus A. If you multiply by minus 1.5, what will happen? Its length will increase that many times. So you can multiply a vector by a number and this will increase its length. Now let us talk about how can we add and subtract the vectors. So in order to add and subtract the vectors, here we have two vectors A and B, right? So we want to add them. We want a result A plus B. So how do we add them? So first I have taken this vector A and I want to add B in it. So I will just put this vector B and join it to A such that tail of my vector B is in contact with the head of the arrow of vector A. Then the resultant vector will originate from the starting point of A and it will end at the final point of B. So by joining these vectors in head to tail order, so head of vector A is in contact with tail of the vector B, you can change the position keeping the direction constant because the vectors are free. That is how we can add the two vectors, right? So another way is you can add vector A to B also. I mean, here we are doing A plus B, and in this second diagram we are adding B plus A in that order. So what will we do? We will put this vector A such that the tail of the A will be in contact with the head of the vector B. Then the resultant vector will be B plus A. And if you see vector R here and vector R here, they have same length, right? And they are in the same direction. So from here we have got one important result, that vectors can be added in any order. You can add them A plus B, you can add B plus A also. Like 2 plus 3 is 5 and 3 plus 2 is also 5. So same, this rule is applicable to vectors also, right? So let's see here. To find the sum of A plus B, we place vector B so that its tail, which tail? The tail of vector B is at the head of the vector A. Which is tail, which is head? So this is head and this is tail, right? So you can add these vectors like that. So then we join the tail of A, the head of B, and the line OQ represent vector R, that is the sum of vector A and B. So this is how we can add the two vectors. Now from where this concept of adding is coming, I'll tell you with the help of coordinate geometry.